Good morning, students. In the last class, we discussed about the polymer and its classification. What is a polymer and how the polymers are classified into different categories on the basis of different heads. Now today we will discuss about examples of some typical polymers. As we discussed in the last class, polymers are two types basing on the synthesis. One is your additional polymer, other is your condensation polymer. On the basis of synthesis, the polymer can be additional polymer or it can be condensation polymer. First of all, we will discuss about the additional polymers. What are additional polymers? Additional polymers are those where the monomer units which are generally unsaturated in nature are added repeatedly to each other to form the polymer without elimination of any other simple molecules. Okay, and the best example of this additional polymers is the polythene, polyvinyl chloride, polyacrylonitrile, polytetrafluoroethylene, polystyrene. Okay, so now we will discuss how these polymers are being prepared. Okay, and what are their uses. So additional polymers. Additional polymers. Number one, polythene. Polythene or polyethylene Okay, so polythene is the polymer of ethene. Okay, when large number of ethene molecules are combined together, we are getting polythene. Okay, so the monomer ethene CH2 double bond CH2. Here CH2 double bond CH2 is the monomer. Now when n number of ethene molecules undergo polymerization, 573 Kelvin, 1500 to 2000 atmosphere pressure in presence of oxygen, you get CH2 N. This is called what? Polythene. This is what ethene. But this polythene obtained from ethene by heating at 570 Kelvin with a pressure of 1500 to 2000 atmosphere catalyzed by oxygen is called what? LDPE. That is what? Low density polythene. Low density polythene. So this low density polythene means what? These are branched polymers. These are branched polymers. So these because they are branched polymers, the monomer units are not tightly connected to each other. So the density is less. Okay, and they are also having some sort of elastic nature. Okay, and when we take CH2 double bond CH2 and ethene, 343 Kelvin, 6 to 7 atmosphere pressure, and for Ziegler-Natta catalyst, called what? Ziegler-Natta catalyst, will get what? CH2 N. This is also polythene. This is called HDPE. Called what? high density polyethene. Okay, high density polythene, high density polythene. Okay, so high density polythenes are the straight chain polymers, so where the monomer units are tightly bound to each other, hence are having high density, they have high tensile strength, and such kind of polymers, so HDP, are basically used to prepare the buckets. Okay, the water tanks, overhead water tanks, are prepared by HDP. Okay, and LDP, the low density polythenes, basically we are using for preparing your carry bags, for simple toys, and soft kind of toys. Okay. Now, so polythene is up to two type, LDP and HDP, low density polythene and high density polythene. Okay. So high density polythenes are obtained when ethene is heated in place of Ziegler-Natta catalyst. Okay, and these polythenes are having the straight chains, the monomer units are tightly connected, hence have high density. Or here in case of LDP, the monomer units here the polythenes are branched, the monomer units are not tightly bounded to each other, so the density is less. Okay. Now number 2. Number 20, polystyrene. So polystyrene is the monomer of styrene. Okay. So if I take CHO double CH2, called what styrene. Polymerization, organic peroxide. Okay, we will have to N. Okay, we will have polystyrene. Okay, so polystyrene is the polymer of styrene molecules. Okay, and these polystyrenes are used for preparing your tires. Okay. Next your number 3, polyacrylonitrile, PAN. So polyacrylonitrile is the polymer of acrylonitrile. That is what CH2 double CHO. Okay, N molecules CH2 double CHO. Polymerization, I take benzoyl peroxide and CH2 single bond CHO N. Polyacrylonitrile or called what PAN. This is called what acrylonitrile. Okay, so acrylonitrile is also called orlone. is also called as Orlon. Okay. Number 4, polyvinyl chloride, PVC. Okay. So polyvinyl chloride is the polymer of vinyl chloride called PVC. CH2 double bond CH2 Cl is called what? Vinyl chloride. Okay. Polymerization you get what? CH2 single bond CH2 Cl N called what? PVC. So this vinyl polyvinyl chloride is the polymer of vinyl chloride. So and PVC are widely used in your water supply pipes. Basically your PhD works, that is in household water supply pipes by using your PVC pipes. Okay. Number 5. Polytetrafluoroethylene. Polytetrafluoroethylene, PTFE, or called what? Teflon. Okay. So polytetrafluoroethylene or Teflon is the polymer of tetrafluoroethylene. Your Cl2 double bond Cl2 and molecules polymerization CF2 N is called PTFE or called what? Teflon. So this is called tetrafluoroethylene. Okay. So polytetrafluoroethylene PTFE the polymer of tetrafluoroethylene. So here the PTFE or Teflon is used for making the coating of non-stick cooking pans. This is your condensation polymers. What are condensation polymers? Condensation polymers are the polymers obtained when monomers having bifunctional groups are added to each other with elimination of simple molecules like water, ammonia or alcohol. Okay, and the process is called condensation polymerization. The condensation polymerization occurs step by step. Okay, so this is also called step growth polymerization. The important condensation polymers are your terylene, nylon 6, nylon 66, and also you are having your bakelite. So now we will discuss how these polymers are obtained as a result of condensation polymerization. First of all, let's see your condensation polymers. You are having a class of polyesters. Polyesters, that means the ester monomers are the ester units. Okay, so one of the most important polyester is terylene or Dacron. Okay, so here the monomer units are ethylene glycol, ethylene glycol. Okay, and terephthalic acid, HOOCCOOH. I can write like this: C double O OH. Here also what you C double bond O OH. Okay. This is what you know, terephthalic acid. Terephthalic acid. So here you see the monomers are two different monomers. So one is what you know, ethylene glycol and terephthalic acid. Now these two molecules will condense to form a single unit. That single unit will repeat over and again to give the polymer terylene. Okay. So ethylene glycol HO and OH. Okay. Will give what you N ethylene glycol and what you know N terephthalic acid. Okay. Now similarly here also the OH will go here. The what you OH will go. So we will get what you O CH2 O C double bond O C double bond O N. This is called what you know terylene or Decker. Okay. So terylene or Decker is the polymer of what? Ethylene glycol and terephthalic acid. Here you see this is the ethylene glycol molecule and this is the terephthalic acid. Now here S and OH removes what? So minus NH2. Okay. So n number of ethylene glycol molecules and n number of the terephthalic acid molecules are condensed together with elimination of what you know n molecule of water will get value terylene or Decker. And this terylene or Decker is one of the most important polymer which we are using in what you know the fabrics like your terrycloth, terry silk. They are being obtained with the help of what you know terylene. Okay. Now polyamines. Okay. In the polyamines, number 2. Polyamines, we have the C double bond O NH group that will repeat. Okay. So number 1, you know, nylon 6. Nylon 6 is the polymer of what you know caprolactam. See, if I take O NH, this is called what you know caprolactam. So when this is heated in some water 543 Kelvin, you get what you know NH2 CH2 whole 5 C double bond O OH. This is called what you know epsilon caproic acid. And this on polymerization, you know, n molecules, right? N molecules here, minus n water, and you get water, NH, okay, CH2 whole 5 C double bond O, N. So this is called value nylon 6. Why nylon 6? Because it contains 6 carbons, 5 and 1, 6. And this nylon 6 are the polymers having high strength. So they are used as fabrics for preparing what climbing ropes, the tire cords. Okay, that's it. Now nylon 6. Nylon 6. So here the nylon 6 is obtained by the combination of the two monomer units. One is hexamethylene diamine, okay, H2NO CH2 whole 16 NH2. What your hexa methylene diamine and adipic acid. What your adipic acid? HOOC CH2 whole 4 CH2 whole 4 COOH. Okay, this is called adipic acid. So when hexamethylene diamine and adipic acid undergo condensation, okay, polymerization here, polymerization, okay, n molecules will get value NH CH2 whole 6 NH C11O CH2 whole 4 C11O. Okay, so here, so this is from this side H and OH. I can take HOH. Okay, so NH C11O. Again from this side also one H will go NH. From this OH will go. This is called nylon 6 6. Okay, why 6 you see? You see 6 carbons and C1 4 5 1 6 carbons. Called nylon 6 6. Okay, so they are also having they are strong. They can be also used for different kind of fabrics and also for your tires. Okay, now your resins. Okay, number 3, resins. So resins are the condensation polymers and where formaldehyde is one of the most constituent particle, important constituent particle in the resins. So basically we can have a phenol formaldehyde resin, we can have melamine formaldehyde resin, and also we can have urea formaldehyde resin. Okay, so one thing we'll discuss are your phenol formaldehyde resins. Phenol formaldehyde resins. So here what we are doing, first of all we are taking phenol plus formaldehyde CH2O formaldehyde HCOOH called what? CH2O formaldehyde. Okay, this is what phenol formaldehyde. Okay, so when phenol and formaldehyde are reacting in presence of acid or base, we are getting what? OH CH2OH plus OH CH2OH. Is called what? Orthohydroxy methylphenol. Okay, and parahydroxy methylphenol. Okay, so orthohydroxy methylphenol and parahydroxy methylphenols are obtained. Now this orthohydroxy methylphenol molecules will undergo condensation to form what? A straight chain polymer called the novolac, and when both the two ortho and para will condense with each other, they will give what a cross-linked polymer called the bakelite. Okay, so we'll go over what OH, CH2OH, N molecules I will take. Okay, polymers on the same condition as plus or OH minus, so I will get what OH, CH2, OH, CH2, OH, CH2. So this is called what the linear polymer. This is what linear polymer or what Novolak or what Novolak. Now if I take the combination of these two, both ortho and para, then I will get what cross linked. You see, if I take so and water, okay, this is what OH, CH2OH plus, this is what OH, CH2OH. Same condition H plus or OH minus, polymerization will get what? Right. Let's see. OH, CH2, OH, okay, CH2, OH, CH2, OH, CH2, OH, again what? CH2, OH, CH2, OH, CH2, OH, CH2, 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 so this is called what cross-linked polymer or the bakelite. Okay, this is what bakelite. Okay, so formaldehyde and phenol condense first to give what ortho hydroxymethylephenol and para hydroxymethylephenol. Okay, now only ortho hydroxymethylephenol also undergo polymerization to give what the linear polymer called the Novolak, and both ortho and para hydroxymethylephenol undergo polymerization under the acidic or basic condition to give what cross-linked polymer called the bakelite. Okay, so this is what cross-linked polymer called the bakelite. Okay, and now next rubbers. Now next we will discuss what rubber. Rubber can be natural rubber, can be synthetic rubber. natural rubber, so we are collecting from the rubber tree in the form of colloidal solution, so called latex. Okay, the colloidal solution, so along with the water that we are collecting from the rubber tree is called latex, and from the latex we are preparing the rubber, natural rubber. And this natural rubber is chemically polyisoprene. That means it is the isomer of polymer of isoprene. Okay, natural rubber called polyisoprene. Okay, so here CH2 double bond CH2, CH3, CH3 double bond CH2. Okay, this is what 2-methyl 1,3-butadiene. 2-methyl 1,3-butadiene. Okay, called what isoprene. Okay, so this undergo polymerization to give what CH2 single bond CH3 double bond C, okay, H CH2 and is called what polyisoprene. Okay, or the natural rubber. So what natural rubber. Okay, the monomer of natural rubber is what isoprene. But in this polyisoprene, the you see this double bond is there. Now this CH2 and CH3 again what here we'll have to CH2. Now this polyisoprene is arranged actually in a cis manner called cis polyisoprene. So because here this isoprene in polyisoprene, this monomer units are arranged in a cis manner. Okay, so there is a gap between the monomer and monomer unit. That means the monomer units are not closely or tightly packed. That's why the polyisoprene can be stretched. The rubbers can be stretched, and they are so soft that in its natural form they cannot be used. We cannot use the natural rubber in its natural form. So by any means we have to increase the strength. That means we have to decrease the softness. For this purpose, the natural rubber is subjected to a process called vulcanization. Okay, so vulcanization is the process of heating the rubber in presence of sulfur, so that the rubber molecules will form a cross-linked polymer with the sulfur, and then after the softness will somewhat decrease, so that we can use this polyisoprene for different purposes. Okay, so for vulcanization of rubber, right? Vulcanization of rubber. Okay, process of heating the natural rubber in presence of what sulfur. So CH2 single bond C, CH3 double bond C, H CH2 one molecule. Okay, plus if I take another molecule CH2, CH3, another one CHO, CH2. Okay, sulfur. Okay, and heat will get what? CH2, C, CH3, CHO, CH2, S, CH2, C, CH3, CH2, CHO, S, CH2. Okay, and so on. This is called what, you know? This is your rubber, natural rubber. If we take N and N, okay, we'll what? N. Volca nitrile rubber. It's called Volca nitrile rubber. Okay. So here you see this is sulfur particles, sulfur atoms are being attached to these two polymer units to form a cross-linked polymer. Okay, and this is increasing the strength of the rubber and decreasing the softness, so that we can use the rubber for different purposes. Okay. However, to meet the need of the hour, this natural rubber is not sufficient. So synthetically, now we are preparing the rubber in the laboratory or the industry. Okay, that is called by synthetic rubber. Okay. Now what is synthetic rubber? What are synthetic rubbers? There are many synthetic rubbers are there. Synthetic rubber, like you have number one, neoprene, okay, or you can say polychloropene or polychloropene, okay. So neoprene is the synthetic rubber, which is the polymer of what, chloroprene. CH2, normal, CHO, Cl. What is called what? 2-chloro, 1,3 butadiene, or called what? Chloroprene. So these undergo polymerization to give what? CH2, single bond C, Cl double bond C, HO, CH2, N. This is called what? Neoprene. This is one of the synthetic rubber. Okay, also called polychloropene. So neoprene is the synthetic rubber that can be synthesized from the monomer chloroprene or the 2-chloro-1,3-butadiene. Similarly, also we have other synthetic rubbers like Buna S, Buna N. Okay, number two, your Buna N, butadiene styrene rubber or Buna S. Okay, butadiene styrene rubber or Buna S, and this is a polymer of what, butadiene, 1,3-butadiene and styrene. Okay, so see CH2 double bond CH2 is called what, styrene. Okay, also CH2 double bond CH2 single bond CH2 double bond CH2 called what, buta 1,3-diene. Okay, polymerization लिखिए what, CH2 okay, CH2 double bond CH2 this is called what, Buna S or butadiene styrene rubber or BSR, also called BSR, butadiene styrene rubber. Okay, the next part, number 3, Buna N. Buna N or you can see nitrile rubber. Okay, number 3, Buna N or called what, nitrile rubber. Now this is the Buna N is the polymer of butadiene and acrylonitrile. Okay, CH2 double bond CH2 single bond CH double bond CH2 called what, buta 1,3-diene plus CH2 double bond CH Cl. Okay, called what, acrylonitrile. Okay, polymerization. Okay, give what, buta 1,3-diene and acrylonitriles polymerize to give what, Buna N or the nitrile rubber. That is what, CH2 CH2 CH2Cl CH2. Okay, this is what, Buna N or what, nitrile rubber. So this is about the different kind of rubbers, synthetic as well as natural, and also we have discussed different kind of additional polymers and condensation polymers. Now let us have a summary of the different kind of polymers and their uses. The summary of the types of polymers and their uses. So here you see these are polymers, different polymers, their uses, and what are their monomers. First of all, LDP, low density polyethylene, where the monomer is your ethene, and the polymer can be used for making toys and bottles. HDP, high density polyethylene. Okay, the uses are to prepare the containers and buckets. We are using HDP, and the monomer is what, ethene. Similarly, PS, polystyrene, the monomer is your styrene, and that we can use for making toys, forms and tiles. PAN, polyacrylonitrile, PAN or acrylon or lon. Okay, the uses are to manufacture carpets and blankets, and that the monomer is what, acrylonitrile. Next is what, PTFE, polytetrafluoroethylene. The monomer is what tetrafluoroethylene, and the PTFE we are using for making gaskets, seals in the pressure cooker, and also non-stick cookware pans. Okay. Now PVC, polyvinyl chloride. So here the monomer is what vinyl chloride, and we are using to prepare raincoats and tablecloths. Then terylene, the monomer is what ethylene glycol and terephthalic acid, and here we are using for making magnetic recording tapes, terracotta, terry wool, etc. Okay. Now nylon 6, the monomers are what caprolactam. Okay, and we are using for preparing ropes and tire cords, automobile tire cords. Now nylon 6 here the monomers are what hexamethylene diamine and adipic acid, and we are using for making climbing ropes and sheets. Okay. Similarly, the bakelite, here the monomers are the phenol and formaldehyde, and we are using bakelite to prepare for making electrical goods and fountain pens. Bunayaso, butadiene, styrene rubber. So here the monomers are the styrene and butadiene, and we are using for making automobile tires. And Buna N, the nitrile rubber. Here also the monomers are what acrylonitrile and butadiene, and we are using Buna N for making oil seals. Okay, so these are all about the polymer chapter. Okay, now next we will discuss about the chemistry in everyday life.